How quick can we be? Data visualization techniques for engineers. So who are we? Alice actually unfortunately couldn't be here today. She is in New York and she was not able to make it, unfortunately. But she's a front-end engineer, she's an senior engineer on Google's crisis response team, which uses software to respond to humanitarian crisis real-time around the world. And prior to that, she was on the Maps team, working as a back-end engineer. I'm Avni, and I'm a senior front-end engineer for Yahoo's Tiger team, and we actually go around every 3 to 6 months on different projects depending on company priority. And I've been a front-end engineer for the past 2 years, and before that, I was actually a database-backed web developer, so I'm coming from the database world. And this is us at the last Random Hacks of Kindness, where we're very sleep-deprived trying to get our hacks done. So I want to first explain how we came to speaking about data visualization. So Alice and I are extremely passionate about open source technologies and bringing women into computing. At the Grace Hopper Conference in October, which, if you don't know, is the largest technical women's conference in the world, we both participated on the Open Source for Good panel. And the panel was hoping to motivate women there who were very new to open source to become involved in humanitarian free and open source projects. And Alice had a spur-of-the-moment idea to challenge the women at Grace Hopper to attend the next Random Hacks of Kindness event. And the Random Hacks of Kindness, or RHAK, is a community of developers around the world working to develop software solutions that respond to challenges facing humanity today. And twice a year, the RHAK core team, where both of our companies are founding partners, hold hack events around the world. And it just so happened that there was an RHAK event happening in December, about 2 months after Grace Hopper. And another issue was, like, at previous RHAK events, there were only about 2 or 3 women attending at each location. So usually the number of women in a technical community or work environment is very few, right? And the number has actually been declining over the last 20 years. So we decided we would set the challenge to an ambitious 20%. We would aim to get the goal of having 20% of the participants be female at each of the 21 locations around the world. And we announced the challenge at Grace Hopper and promoted it via Facebook, Twitter, LinkedIn, the usual methods, and also a scholarship for 1 female participant. And after the event, we wanted to see, well, how many of the locations actually reached 20%? So in several locations, we were quite successful. For example, the Chicago location, where we hit 31%, the winning hack was actually comprised of 4/5 female, which was pretty awesome. So we also wanted to represent this data we collected in an easy-to-comprehend manner. The data from the RHAK event made it very clear that we're really far from getting to 50-50 in terms of gender ratio. So we wanted to present this data so people actually feel shocked when they see it and are perhaps compelled to raise awareness and take action regarding the gender disparity in open source and in computer science in general. So data visualization is not something either Alice or I are experts at or do every day. And we have, due to our day jobs, we have like a limited amount of time to explore. But we wanted to see what we could do with the data we had. And we talked to colleagues and found out that this is actually an interesting problem, right? A lot of engineers, even front-end engineers, don't think data visualization is easy. And we wanted to see if this was true. So we gave ourselves a challenge to explore data visualization techniques, and the idea of the talk began to form. So I want to first show you the raw data we had. So as I mentioned, the challenge that we put out was a spur-of-the-moment idea. And we didn't have a data collection process in place when we made the challenge. We kind of just did it. So we had like an online event registration system, but at each of the locations, people just wrote down their names when they came in. So we didn't have an online record of who came to each hack or the gender of the people who attended. So this is a snapshot of the original data set. And we had 1 row per participant, but we didn't have their gender. So Alice and I went through like 1,500 rows and manually entered in the gender for each location. And we contacted colleagues around the world, like asking, like, is this male or is this female? And we removed, like, as we learned today, there are names like Jan, which are both male and female. So we had to remove that data. So we still ended up with over 1,300 valid names, though, with gender. So we thought that's a good set of data. And now that we had all this data, though, we wanted to figure out a way to present it in a manner that is easily digestible by the public and by the RHOC core team. So we first aggregated the data so we could see how each location fared using spreadsheet formulas to help us. And we then wanted to start looking at, okay, different tools to help us visualize the data. And we decided on the following process. We would start with a set of tools to evaluate. We would take 10 minutes to see if the tool is a viable option, and if we found the tool to be viable, we would explore the tool further to reach our desired goals, with our goals being, 1, to plot the number of people at each location, 2, to plot the percentage of women at each location, and 3, be able to plot both 1 and 2 on the same chart. 4, clearly show the gender disparity, and 5, be able to use this tool to easily visualize data for future RHOCs, because we want to continue the challenge and hopefully slowly increase the goal percentage as more and more women attend. And we also decided that we would take like 1 hour with each tool so if we could reach this metric of success. So the first tool we started with was OpenHeatMap. So OpenHeatMap is it's an open source project implemented by Pete Wardner, and it uses the OpenStreetMap tiles to draw the maps. And the service is designed to make it easy for non-specialists to create maps for communicating information. And we're like, oh wow, that's us, right? Non-specialist, this could be a dream tool. So for developers, there's a jQuery plugin that makes it easy to create an open source mapping component on any web page. So I want to show you a quick demo of us actually using the tool with our aggregated data so you can see how easy it is to use. Let's see. Sorry, I lost my mouse. Where'd it go? Do you guys see it? Completely lost it. Okay, try again. Huh? Okay. All right, here it is. Yay. Thanks. So let me make it larger. So you can easily come here and you can upload a CSV. So we uploaded our aggregated data set. And then basically, if it thinks the data is valid, what it will do is basically say, okay, your data's loaded, click here to view the map. So then you can view your map right away. And right away, it gave us a heat map of the data that we had. I can hover over the markers to see any specific data points, so I can see the percentage of women at each location. The large blue circle is Columbia there, and it's actually a really big anomaly, and we removed it from later examples we did because Columbia was a satellite location, and it happened to have, it had one person there, and it was a female, so that's why it looks so big. But you can come in here, you can customize at the bottom, you can customize certain parameters, you can customize the title, the color, it has a few color schemes, the size of the circles. And you can also show other, you don't have to use circles, you can use blobs and some standard images. So then when you finalize what you want, you can save and view. And voila, you got your map with the parameters that you set. This is nice, this part is nice because it actually shows a nice legend based on the data you have. And we actually learned a lot of tools don't, even the programmatic ones, don't come out of the box with a legend. It does have this weird thing, I don't know if you can see, but it came up with a weird name. It's like Dionysian fusion. I mean, it came up with a weird name for the URL, and there's no way to actually change that. So that was kind of unfortunate. So, but as you can see, the tool is very easy to use. That was completely real time. And you just go to, it's at openheatmap.com. And I like that this map made it very clear which were the high percentage women areas. Like I can look in this map, Columbia's been removed here, but I can look at this map and easily see, okay, Northeast United States, a lot of women attending. Surprisingly, the one data point I was really surprised about was the the Zambia data point in Africa, because I was like, I didn't know there were a lot of women programmers in Africa, but there were close to 30%. And we later learned, there's actually a blog post on RHOC right now, on the RHOC website about this, but there's a women's group in Africa based in Kenya, Akira Chicks, which actually encouraged women to go to the hacks. And I mean, I thought that was pretty powerful, that if you have the support team there, that you actually do have women participating. So far, this seems like a dream tool, but then we realized some limitations. Once you create your heat map and you left the edit window, you can't go back and change the parameters. So I couldn't go back, like I had first plotted it based on percentage, I couldn't go back and change it based on number. So there was no way for me to edit it. I would have to create a whole new map. Also, since we used a CSV to upload the data, there's no way we can edit the raw data. So there was no way we could edit the numbers. Like I couldn't remove the data, the Columbia data point, which is kind of annoying. You can create a map directly from data in a Google spreadsheet. It will, as long as your spreadsheet is public, and then your map actually does get updates automatically if your data in your spreadsheet updates. And as we saw, the generated URL is predefined with some arbitrary name. So the solution which gives you more flexibility, though, is to use the jQuery plugin, right? To host the heat map on your site using the heat map API. However, we tried to use the API, and we used the same data file, but you actually couldn't. You had to understand, you had to geocode your data manually, and you had to be familiar with the OpenStreetMap tiles to understand how to use the API, and the documentation is not very clear about that, so we decided to move on. Pete, the author, he's like really responsive on to GitHub messages, so it's something worth checking out if you want to look into it more. So we realized at this point the tools could be broken up into two paths. We would have the non-programmatic ones and the programmatic ones. And so we thought we'd look at several tools of each type. For non-programmatic tools, we decided to look at OpenHeatMap, which you just saw, Google Fusion Tables, Google Charts, Socrata, Chartspin, and Factual. Chartspin turned out to not be a good option because it doesn't allow you to upload your own data. Like, it has some interesting data sets up there, but I couldn't upload anything of my own. And Factual was not a good option either because it doesn't provide a map view of our data, so it wasn't a good use case for us. Now, the programmatic tools that we looked at were the Google Maps JavaScript API, the Yahoo Maps web services, the Bing Maps Ajax control, and the Google Charts tools using the visualization API. So I'm going to talk a little bit about both. I'm going to start first with the non-programmatic ones, but I will get to the programmatic ones at the end. And the one, I thought this is probably like the coolest find for me at least, which was Google Fusion Tables. Like, Elise already knew about this. But I want to show you a demo also so you can see how powerful Fusion Tables is. Okay, so I can come here. Let me get larger again. I just go to the Fusion Tables site. I say I want to create I want to import data from a new spreadsheet. I select the spreadsheet I want to import from, and I can easily do that. So we're using our aggregated data set again. One thing that, and I'll explain this in a minute why, but we did have to add a column for country that just had the country, and I'll show you in a second why. You can give it a name and some parameters. And then right away it gives you a table, right? And it automatically detects, now this was just spreadsheet data, raw data, it automatically detects that my two columns, location and country, are location-based, and it highlights them. So when I go to create my first simple map, I go to the visualize field, and I say I want a map out of it. It automatically starts geocoding based on one of those columns. It chose location, which is what we wanted by default. And right away, I get data points. So this shows me quickly all the locations where the hack took place. And if I click on one of the locations, then I can see details about it. I can see the total number of people that attended, the % female. Now, this is great, but it's not ideal, right? Because I can't just look at the map and see which ones have the largest number of women or which ones had the most attendance. So Fusion Tables also offers what they call an intensity map. And this is pretty cool, because right away what it does is it basically takes the data I have and then color codes countries by default. and I can hover over, and I can see the total number of people. Now, the one thing that was odd, though, is it actually, like you can see here, for Canada, it's okay because we only had one location in Canada, and the total number was 80, so that was correct. But if you go down to the US, it's only showing Seattle's numbers. Like, there were way more than 25 people attending the hacks in the United States. So that's where we had that country column came into place. And Fusion Tables actually has an aggregate option where you can select, okay, you want to sum or over a certain field, and we want to sum by country. And we're able to see the aggregate data. Now, the problem is, like, there was some glitch, so I actually had to go to another value and then come back, and then it showed the correct data. So now I can see, okay, 377 people attended in the US, so that's actually correct, and it's aggregated by country. There's also a few other neat things you can do. You can, let's see, which one did I do next? You can actually view markers. So with the data non-aggregated, I can view markers, and then it plots points. The problem with this is great, right? So this is giving me the same thing OpenHeatMap did, but this shows the number of people that attended, but I can't see the percentage of women. So it's only one, it's again one-dimensional. It's only one set of data that it's able to handle at a time. And if I go back to regions, I can narrow in on a certain area also. So if I wanted to narrow in on the United States, it has a search assist, and I can see for each region how many people attended. I can also add a filter. So I know that our goal was 20%. So we have 6 locations in the US. I want to see how many actually reached the 20%. And I can see, okay, great. Four of the locations did. So this is actually being done pretty much real time. Actually, this is all real time. The earlier import, I did speed up a little bit. Okay, now if I go back to maps, I can also do custom markers here. So this is like a great playground for if I just am seeing what I can do with the data. So if you, like, I think Fusion Tables is great, like if you wanna, like if you don't know what you want out of your data, but you just wanna play around with it, see what's possible, you can use it to do that, and then actually maybe when you decide what you want, then use a programmatic version, like use JavaScript to build your final version. So here I decided to break my data into buckets, and I'm saying I'm going to have green pins for greater than 20%, yellow for between 10 and 20, and then red for less than 10. All right. So this shows me pretty quickly that the US was at least above 10% in all their locations, which is pretty cool. Now, this is again one-dimensional. So Fusion Tables does you can plot 2 dimensions of data with scatter plots. And here I'm plotting total number versus percentage, right? And this actually shows me pretty quickly that the x-axis is number of people. So the more people that attend, the more likely I am to get towards the 20%. I was at least above 10. There was one exception, which is Argentina, which was 9%. But I thought that was pretty cool. The scatter plot, actually info window, didn't show the location, so it only shows you in the info window what the X and Y value is. So that was kind of a limitation. Here, the pie chart and the line chart, I can easily see which location has the most number. India had the most number of flat people. The problem is or Bangalore location had the most people. I think the problem is, again, it's only one dimension of data. Okay, so here again is the chart where we're using the aggregated counts to show the number of people in each country. And in Google Charts, there is a heat map gadget you can use to plot data. And this is a heat map of the number of women who attended aggregated by country. And you can actually access this functionality directly from Google Spreadsheets. There was a little bit of difficulty plotting the data. You need ISO country code, and it has to be done manually. And you also need aggregation counts. So your aggregation counts had to be done manually also. It wasn't like Fusion Tables where it actually calculated it for you. So for non-programmatic tools for heat maps, like Fusion Tables is much more powerful than Google Charts. The Google Charts does have some interesting things that I'll talk about a little bit later. The next tool I want to talk about is Socrata. So Socrata is a company working on open data services for government, and it provides a platform to help you share data with others. So it's used by the city of Seattle. You can go to data.gov for examples. And they have a way to also upload your data and visualize them using various Maps APIs. It's a little bit less trivial than OpenHeatMap, and it seems that Socrata's main use case is to quickly allow visualization of existing data on the platform. So you can choose between Google and Bing and ESRI maps. Like the upper left is a Google visualization, and the lower right is ESRI. And in 3 minutes, we were able to create an account and upload a CSV to plot the heat map of the country. However, like if you want to plot data that's in a location other than country or a US state, you are required to actually geocode your points. And it is a little bit slow to render. So it's a great way to visualize existing data sets, but it's probably not a perfect tool for just one-time data use. Okay, so then we moved on to the Google Maps API. And we created a Maps key to use in our application, and we found out pretty quickly that we could plot individual markers of data using our aggregated data set. So much like what Fusion Tables had, we were able to come up with the same with the Google Maps API. So it was very easy to take our summary data points, plot them on a map, and open up a window with the number of people and the percentage of women in that info window. So we first initialized the map. I centered around Chicago, I think, here. And then I set the map options, and I chose a road map to use. I created a new instance of the map in my map canvas div. And the locations data was a simple array, right, with the columns being location, latitude, longitude, number of people, and percentage. So I plotted the map. Let's see, so we just loop through the data, we create a marker for each location, and we add a call to set markers in the initialize function. So then to add the info window, we basically have a little bit of a script which builds the content in the info window itself, pulling the data from the array, passes the data to the marker, and then adds a listener so that when a user clicks on the map, you get the info window. You add a new instance of the info window in the initialize method, and you get the map we looked at before. The data points, like as I mentioned, still don't make it very clear from one view the number and the percentage, right? I can click on a point, but it's not the same as if I was able to see it once. So we kept looking, and we came upon Marker Cluster. So Marker Cluster is an extension to the Google Maps API written by Frank Wu. And this is a plot of the number of women that attended each location using the extension. So if I know that over 1,300 people attended the hacks, I can quickly see with this map that women make up a small part of the total attendees. And I love the graphics, but this chart still doesn't show me the ratio of men to women, so it's difficult to grasp the disparity. If you want to use Marker Cluster, though, all you had to do was include one file. The data did have to be one row per person, though, and what it does, we had one row for each woman that attended as like in a JSON object, and the Marker Cluster would then actually cluster the data for you. So if you had 30 women in one location, you would have 30 data points, and then the Marker Cluster would cluster all those points and make one marker for it. We looped through each of the data points and created a new cluster marker, and then we added the layer to our existing map. The another weakness we found for Marker Cluster is that there was no way for the tool to use different data. Like we couldn't use like the female or the percentages, or it basically used the number of data points you had in your data. So, and there was no way to use a field that you designated to say, okay, the number I want to appear in my map is based on this field. And as we saw, this was the result. So the cluster uses both the size of the marker and the number inside and the color to plot the same data, right? So it would be really cool, it would be a really cool extension if we could say that the size of the marker represents the number of people that attended, and then the number inside represents the percentage of women, or something like that, so you can see two sets of data on one map. One nice feature about the marker cluster, though, is the drill down capability it provides. So when I was looking here, I was looking at a zoomed out view, so it's showing me only numbers per country. When I zoom in on the map, it automatically, I'm zooming on the US here, it automatically shows me the numbers in the US. So we feel like we're making some progress, but there's still not clear visualization which shows the number of people who attended versus the percentage of women. So we continued exploring, and we came across layers in the Google Maps API and found a layer for the Fusion Table heat maps. So we saw the possibility of integrating our Fusion tables with the Google Maps API using the Fusion Table Layers class. And we're like, oh, cool. We can use the Fusion tables we have. We don't have to export a CSV or anything. And create a heat map with the Google Maps API and plot markers on it, and we'll have what we want. So we started looking, and then we found this is the example Google Maps API with Fusion Table heat maps, and it's plotting beaches in Brazil. And what it's actually doing is plotting a single point for each location. So much like what Cluster Marker had, you have to have one row for each data set. And so this wouldn't work with our aggregated data where we only had 1 point per location. So the integration of Fusion Table and Google Maps API to generate the heat map didn't fit our use case. It might have been possible to do with individual data, but I think the heat point still came out really, really small. So we'd have to multiply it by a lot to get anything really visible on a map. If you want to do it, though, here's how you do it. And it might be valuable. It's valuable if you want to use your data directly from Fusion Table. So here, I'm just accessing that's the first parameter to the Fusion Tables layer instance is my Fusion Table ID. So as long as it's public, I can access it. And I can pass an option to set heat map to true. And then I can add the layer to my map. So the heat map option is probably not suited for aggregated data, though. So we then came across the Circle class in the Google Maps API. We started with an initial basic map with plots of all the cities, and we used the same data set that we had in the basic map. We first plotted circles where the size was based on attendance. So you can see here, Argentina, India, Zambia, and the Northeast US had probably the most number of people attending. So creating circles was really easy. We basically we passed the circle options where we indicated the color of the circle, the opacity, and the radius, which we did still have to multiply by 3,000 to get significant size circles, but we passed the number of people that attended, which was our 4th data point in the array. And we passed that to an instance of a circle. So that was easy. And then we're like, okay, well, that was easy. Well, why can't we just do different color circles based on the percentage, the value of percentage, right? So we can do the buckets again. So we did that pretty quickly. So we used the 5th data point to say, okay, if the percentage is less than 10, color is red. If it's greater than 20, it's green, else it's yellow. And then we passed the color to the circle options to get this. So now, again, different sizes are based on, the size of the circle is based on attendance, but now the circle color is based on percentage. So it's easy to view which places had a lot of people and also to gauge the relative percentage of women. And if you remember, like when we did the open heat map screencast, Columbia was really big, but here, now it's saying, okay, Columbia only has 1 person, so you can't barely see it on this map, which I think is more accurate representation. So it shows you both sets of data. Now, if I want to get more detail about each one, I can add back in a call to set markers and info window. And now I can click on each point to get more detailed information about each map. And you can actually also tie the info window to the circles themselves, so you don't need the marker points. Actually, we have a blog post up on RHawk right now, which has this map up without you can actually click on the circles directly. Another thing is the circles automatically scale to your zoom level, which is pretty cool. Okay. So then we looked at Yahoo Maps web services and also Bing. And this is the first map we created with the Yahoo Maps API. So we had explored the Google Maps API extensively, and we wanted to see what Yahoo and Bing also had to offer. And it turns out the APIs are all very similar in structure. The function names are different, but the structure is the same. So you create a map, you plot the markers, add event listeners for the click to get the info windows. One thing I didn't like about the Yahoo Maps was the default marker. So I went ahead and I found a class to use the custom to add your own custom icon, and used the same icon that Google Maps has for my Yahoo map. And I came up with this. And so I like this a little bit better. Now, all the APIs offer the ability to use custom icons, and it's done in a pretty much similar manner. So you just create a new image, set the source, set the size, and for Yahoo Maps, it does offer an option to actually move your marker, move your window around, like offset your window based on your marker. And then you make sure to pass the icon to your marker. Now, when we looked at the Bing Maps, so this was the map, and when we looked at the Bing Maps Ajax control, it turns out that their API is also very similar in structure. So this is a street view, and one advantage that Google Maps does have is the street view. So street view is available, I'm sure almost everybody knows about it, but it's available by default when you create your own map using the Maps API, and we thought maybe this will be useful in the next RHOC. Because to use before the event so that people can actually find locations of hacks, because you're usually going to a new place. This is actually where we had the Chicago hack in December. It's the CNA Insurance Building in downtown Chicago. Okay. So next we looked at the Google Charts tools, which uses the visualization API. And you can use it to embed an interactive chart, graph, or other graphics onto your web page. And the visualizations are interactive and also expose events, such as user mouse clicks enable you to write code to create great effects on your page. So you can embed a visualization either using JavaScript or an embedded gadget. What we did earlier was a gadget, but you can also use the API to build your own and host it yourself. Now, if you use JS, there's still the same limitations we encountered when building the gadget. You need ISO country code, and it has to be done manually, and you have to aggregate the data yourself, and that also has to be done manually. And you can't plot cities, which is kind of a limitation. It does provide a pretty good legend, but Google Charts is a great way to plot like multiple charts synchronized with each other on the same page. So if you have multiple charts and you want two things happening to the charts at the same time, it's a great option. And there's also, it offers a large variety of options like table, bar, line, and some interesting custom ones. I actually saw some speedometers in their examples, which looked pretty cool. So they're constantly improving, so it's definitely something to look at also. So in conclusion, if we take a look at all the tools together and their capabilities, when we first started out, like the goals that you saw at the beginning, we really weren't sure what we wanted. But those goals, like we came up with those at the end. And these criteria that you see across the top, we kind of came up with those after we had done all the research, because we weren't really sure. But we realized what we really wanted was to be able to visualize two sets of data. We wanted to see if it required coding or not. We would have liked it to be easy to make a legend. We also evaluated it on how easy it was to create the first map. And do we get full control or not? And you can see from this that the more control you have, I guess the more control you have, it gives you the power to visualize two sets of data, right? Because you can really build what you want on the map. Whereas if you have less control, it's you're not able to visualize the two sets of data. I think the other thing is, as I mentioned earlier, like Fusion Tables was really powerful, like if you're just exploring data, but if you know what you want, then maybe then using like a programmatic tool, such as Google or Yahoo might be what you want. So some more conclusions. It's very easy to plot flat numbers with most tools. Plotting multiple sets of data without code, though, is not trivial. And Flash graphics still are ahead of JavaScript graphics with respect to data visualization. And I forgot to mention this, but Fusion Tables actually inputs your data into a Flash object to produce those maps, whereas the Google Maps API is all JavaScript. Most map and charting tools need better overall legend support. The Maps API products are very similar in structure. Yahoo is actually coming out with, they're at I think they're at version 3.9 right now, but they're coming out with a version 4, which people on my team are working on. and it's using the Nokia, the OV backend. So I'm really excited to see what they have there. We've just uncovered the tip in terms of data visualization. There's a lot of options out there, and that 1 hour limit we had set for ourselves, we were not able to adhere to that at all because there's just so much information, and it took us a while to go through everything and figure out how to get what we want. And our visualized data showed us that the more people that attended the event, the more likely we were to meet the 20% challenge. We do need to improve and automate our data collection process as much as possible. For the June RHOC, we're using Eventbrite, and we're hoping to scan people in as they come, and we're also collecting gender, so it should make it a lot easier. We definitely need more women hackers still, and when women do participate, like they did in Chicago, they win. Okay, that's it. Questions?
So in what way was Splash superior to JS in terms of vision?
Well, it's easier to get maps where you can actually color in the whole region. Like if I was coloring in the state or I was coloring in the whole country, that was much easier to do. I think Google Maps actually provides, somebody has built out where they actually plot those specific regions, but it's not, you have to actually use that extension. It doesn't come built in. Okay, any other questions? Okay, that's it. All right, thank you. All right.
Laura, did you remember to load the bacon?
Oh, I knew I forgot something.